For the water integration, generally for the integration we just do for saving the water. So for not using a lot of water, but we just have to, our aim is to do the recycling the water. So here we just have to take the some three processor. I just assume that three processor. I just took it from some reference paper, and I assume these are the values um, for calculating water integration and with using the pinch technology. So first of all, this is the diagram. The water will enters into this process with certain contamination, and then it will involve in some compounds and then come out with some contaminant loads of water. So the water flow rate we just measured as MW, and the inlet concentration is Cn, and the outlet concentration is C out. And the overall this is called the increase in the contaminant mass flow is delta MC is this is the formula like MW into a difference in concentration. So first we'll just draw the graph for these values. Like in the x-axis we just take the MC value, and in y-axis we take a concentration value in ppm, and here it's kg per hour. We just took the values in kg per hour. So firstly here the concentration value, like at 0 to 400, at mass at 10 kg per hour. So when we take the 10 kg per hour, so we just have to draw this from 0 to 400. These graphs I just took it from here. Like we have to go to the insert and select the shapes. Here you can get this line value, line shape. So from this I just draw these lines like from here to here. Even these values also I just took it, depends on the values. So at the 10 we just draw this 0 to 400, and from here at the second point, so the contaminant mass at 15, so we just have to add this 10 plus 15, so this will be like 25. So we'll here the value is like concentration value is 200 to 400, it will vary. Then at 25 means that 10, 15 and 25, the overall is 50, 50 kg per hour. So here the values are varying from 200 to 700. These are the um, lines, points varying from one initial concentration to final concentration. So from this, after that we just have to calculate the um, concentration intervals and contaminant loads. So firstly we just have to calculate the limiting water flow rate. So for these, if we observe like the values, we just segregated this, we just separated these, like this one from here to here, this will be like C1 this level, and from here to here it is C2, and this is C3. So when we are calculating the limiting water flow rate for C1, the flow rate will be like only 25 tons per hour. So when you observe here, the first lines, from here to here, the limiting water flow rate is 25. So from here to here, the same value will carry 25. So but when it comes to this 200 to 400 level, the three flow rates are involving. So we just have to add the three limiting water flow rates, like 25 plus 75 plus 50. So like that I have included, so that we'll get the new limiting value. So the second one is 150 ton per hour, and the third one is only one limiting value is here, that is called C3. So the value will be like 50 tons per hour, it's not changing anything. So only the second value is varying. So after calculating the limiting water flow rate, we just have to calculate the new contaminant mass. So this new contaminant mass is the we are using the formula here, like MW into delta C. So when we get the new limiting values, we just have to do, and the concentration also will vary. It will be like the flow rate will vary from 0 to 200, because the values, the C1 will be like it's varying 0 to 200, and after that then 200 to 400. So the C3 will be like 200 to 400, and then like the the process is 400 to 700. So like that we just changed concentration values, and after that we use that formula equation. We use this equation and we'll calculate the contaminant mass. That will be like 25 into the concentration difference, so we'll get contaminant mass in gram per hour. So after that, we just have to draw another graph for these new values. So when we draw the graph, we'll just this blue color line is a new composite curve. So after completing these two, these are the old, the red one is the old values, and the blue one is the new concentration values. So when we draw these two, we'll get the one pinch point, which will be like drawn in the green color. So it shows the pinch point. The pinch point is at exactly 400 ppm. So from these points, we just separated the regions, like region 1 and region 2. It's like from here, this point, the pinch point, for example, below remnant mass, this will be like region 1, and above is like region 2. From here, we have to calculate the minimum flow rate in design region. So for the minimum flow rate at pinch, for delta mcp pinch and delta c pinch is like, so we just have to add the flow rates, like here how much we are getting, like mass contaminant value 1 and 2. The region 1 is including these two values, so that's why you just added. So the value will be like 3500, and the flow rate will be like vary from 0 to 400. So it will be like difference is 400 minus 0, so that the total value is 87.5 ton per hour. So when it comes to the region 2, so the same will be like only region 2, the overall, the total, the three will include, and minus will have only the third one. We just have to do only for the third one. So we just have to minus the 3500, and by the flow rate will be like 700, and minus 400, so the total will come 50 ton per hour here. So after calculating all these, we just have to do some flow sheet for that, like the how the water is going for the three processes. We will just doing that the process one, the water will 25 tons per hour, and for water process 2 it will be like 37 point, and we are sending the 25 tons per hour to the process stage. So the overall it will comes like uh, combining these three processes, it will come wastewater 87.5. So here the main point is like we are just reusing and recycle and everything we are doing here. So but when it comes to fresh water for all the three processes, if you use the fresh water for three processes, what will be the value? So the same, like we just have to we have taken these initial values, and all the concentrations are zero, and the final concentration is this. So and we calculate the water flow rates. From this, our fresh water use for all three processes are 98.2, and for our values and the freshwater values. So when we compare these two, we are getting like 10.7 tons per hour saving water. So using instead of using fresh water, we can use this pinch technology method. We can calculate the water integration by pinch technology, so that we can save some water. This is water integration.